In this video, we will give a brief overview of our work. Mixed dual-head meets box priors, a robust framework for semi-supervised segmentation. Aiming to reduce the allocation cost of semantic segmentation, numerous weakly and semi-supervised methods have been proposed, but they face two main problems. First, their performance fails to meet the needs of real-world applications. Second, the way to utilize multiple types of supervision needs to be further explored. So our goal is to train semantic segmentation models using fully labeled images and weakly labeled images with bounding box labels. We focus on two main aspects: generating high-quality pseudo-masks and improving the training stability. Our method contains two networks, an annotation network, or annet for short, and a segmentation network, or segnet for short. The annet is used to predict pseudo-masks for weakly labeled images, and the segnet is the resulting model for deployment. We first train the annet using fully labeled images with ground truth masks and weakly labeled images with proposal masks. Then pseudo-masks for weakly labeled images are predicted by the trained annet. Finally, we train the segnet using fully labeled images with ground truth masks and weakly labeled images with pseudo-masks. To train the annet using weakly labeled images, it's necessary to obtain pixel-level labels from bounding boxes. We use graph-cut and MCG to get proposals of each object, and fuse the graph-cut and MCG proposals in two steps. First, we fuse the graph-cut and MCG proposals for each object. Then we put each object's proposal back to the correct position in the original image. To guide the training of annet, we extract position and class priors from the bounding box to form the 5-channel input for annet. We use the distance from each pixel to the bounding box to construct the position priors. The position priors map can be regarded as a heat map, where smaller values indicate a higher potential for the existence of an object. We use the bounding box classes to construct the class priors map, which encodes the possible classes of foreground pixels. We can split the semantic segmentation networks into the feature extractor and the prediction head. There are three ways to utilize both strong and weak supervision. Single head is a commonly used structure. It supervises the prediction head with a mixture of strong and weak supervision. The label noise of weakly labeled images will greatly affect the performance. Dual head uses two prediction heads, which are supervised by fully labeled and weakly labeled images separately. This design can reduce the factor of label noise, but the strong head cannot be well trained when there are few fully labeled images. The proposed mixed dual head supervises the strong head with a mixture of strong and weak supervision, which can improve the training robustness while reducing the interference of label noise. We evaluate our method on VOC dataset. We train our method using about 1,000 fully labeled images and 9,000 weakly labeled images with only bounding box labels. It can be seen that our method outperforms the fully supervised baseline by a large margin under different backbone networks. We mainly compare our method with self-correcting, which also uses bounding box as a weak label. We can get a better result even with a weaker backbone. From the qualitative result, our method can produce more accurate segmentation results than fully supervised baseline. Thank you for your time.